The table gives estimates of the world population in millions from 1750 to 2000. Use the population figures for 1750 and 1800 to write an exponential growth model and predict the world population in 1900 and 1950. So here we have years and then a year's continuation and then the population. So what we're trying to do is we're trying to use our population figures. So we're using the 1750 and the 1800, and we're using those to create an exponential growth model. And then we're supposed to use that model and predict the population in 1900 and 1950. And we'll be able to see how close the model from 1750 and 1800 is to the actual population that was recorded in the table in 1900 and 1950. So where should we start? Let's start with writing some information down that we have. So first of all, we know that we're going to be looking for a population model. So let's say that we're going to let P of T be our population model, so equal our population in millions. So we're going to create a model and we're going to let P of T be our population in millions. All right, so P of T is our population in millions. Let's say let T equals 0 be 1750. Because we're told to use the figures for 1750 and 1800. So let's start there. Let's see if we can start there and see what we have so far. So we know our equation, and our equation is going to be our P of T equals CE to KT. And we know C and K are constants. So we're going to have to use some of our other values to figure out our C and our K. So let's start with that. So we're told to use 1750 and 1800. So 1750 would be our initial. So that means that our initial population from 1750 is going to be our C value. So that's 790. E, we don't know the K, but we're told that we should use 1800 as our second value. So that means that our time would be 50 years. So if we're looking at our P of 50, because our time has been 50 years, well, P of 50 for 1800 is going to be 980. So that means that we'll have 980 equals 790 e to the 50k. So let's pause right there for a minute and make sure that we understand our equation that we've written so far. So we were given our time, our initial time, so our time of 0, our initial time was 1750. So after 50 years have passed, that means we're at 1800. So our population after 50 years is our 980 for our 1800 population. So 980. Remember, it's in millions. Our initial, when our time was 0, that's our C value, and that was our 790. We have 50 years, so our time was 50, and now we have enough information that we can relate the populations from 1750 and 1800, and we can find K. So the first thing we should do is sum division. So if we divide both sides by 790, then we're going to get 1.24 is equal to e to the 50k. Then in order to get the k out of the exponent, we need to take the natural log. The natural log and the e are opposite of each other, so those are going to cancel. The natural log of 1.24 is 0.216. So that equals 50k. So if we divide both sides by 50, then it looks like our k value will be 0.0043, and that's our k value. So now we've got our k value. So now we're making some progress. We can keep going with trying to write our equation because we now know C and we now know K. So let's see what we can do from here. So this means our P of T is going to be, we have CE to the KT, that's our original formula. but now we can fill in some other information. So P of t, our population at our time t, we know our C value now. That was our 790. E, we know our K, that is our 0.0043. And then we don't know our T because we're just writing our equation. We'll figure that part out in a minute. So now we have our new formula, and that is our exponential growth model. Now it's asking us to predict the population in 1900 and 1950. So let's think about this for a second. We said before that T of 0, excuse me, was 1750. So that means if we have 1900, that will be T of 150. So let's put that in. So that'll give us P of 150 equals 790 e to the 0.0043 times 150. Now remember, we're not looking it up in the table this time because we're using our model to predict, and we'll see if we were accurate to what the table value was. So we can type this in. So if we keep solving down, we'll have 790 e, and then multiply this all together, and it should be 0.645. And then type this into your calculator, and we're going to round, so we'll have 1505 million. So how'd we do? The estimate was based on the 1750 growth rate. Looks like it wasn't that accurate. In 1900 in our table over here, we have 1,650 million. In our calculation based on our model, we have 1,505 million. But it would make sense that the population growth rate in 1750 would probably be a bit different than the population growth rate in 1900. So it makes sense that they'd be a little bit off, but it looks like it was a little bit off. Let's try the next one. We were also asked to predict the world population in 1950. Well, if we have 1950, that means that T would now be equal to 200. So we can plug everything in just like we did. So we need P of 200, and that would equal our 790 E. And then we have our K, so 0.0043 times 200. And then we need to solve it down. So if you type this one in, remember, do your exponent first, and then do 790e, and then raise it to what your exponent multiplication was. And it looks like it'll be about 1,867 million. So again, a little bit different than what the actual population was, but that's okay. We used our model to verify and check and calculate the population based on the model from 1750 for both the 1900 and the 1950.